it said the sample, find the confidence interval for the mean. For the mean, right there in that wording. Okay? So do some calculations. Pull out that calculator. 4.2 divided by radical 250. Let's hear it. And it's going to be the same exact idea where we're going to multiply against the t-score, add and subtract from the mean, and hit our interval. And it's the same wording as well for our interpretation. Except instead of sample captures the true proportion, we're going to say captures the true mean. We're just going to reword the wording there for a second. 4.2 divided by radical 250. Oh. 0.27 basically. Is, you got 0.27? Yeah. I used 266, something like that. Okay. That'll be awesome.
Every time you get a text.
That'll be so awesome. Now on your on that formula sheet, it also goes through where you have the mean, plus or minus, critical value, I think it said, and then standard deviation. So it's the same type of formula that's going to go through. We're going to take the mean, the sample mean, and we're going to add, and then we're going to calculate it where we subtract to find that interval. And it's going to be the t-score times the standard deviation. So it's the same format as before. The 10.2, so you don't have to worry, Caleb, about making the whole outline again. It's really the same idea, except we're using a t-score. Now the other thing is, when you look at something like this, when you're trying to figure out the proportion, there's no way, we don't have that information in this problem. We didn't have, of the 250 students, 200 of them spend a lot of time doing homework. So it didn't make sense to do that proportion inside that standard deviation anyways. You had to use a different type of formula. Because we don't have a P. We can't calculate the percent that this actually happens. See what I'm saying? Yes, Caleb?
With the other one, the other tip, when you use the z-score, it would be P plus or minus the standard deviation of P hat times the z-score.
Mm-hmm. It's the same thing.
The standard deviation divided by the square root of n, the same thing as the standard deviation of P hat?
Yeah. No, they're different things, because what they are both standing for standard deviation.
More for the same thing?
They're both definition, or both formulas for standard deviation. But one of them is for when you're doing sample means, and one of them is for doing sample proportions.
So they're different.
So technically, yeah, they're different formulas. Like the other formula that we were using last class was this one. But we can't use this one. We don't have a percentage, and then we don't have the opposite percentage there to use. Like we were using 0.7 and 0.3. We don't.
So
we're with the 0.7, and we don't have that in this formula because we're not doing proportion. We're doing a mean.
Okay,
So it's based on this formula over here. I think it's even on that formula sheet. I'm sure.
Is it just what's in the parentheses, like beforehand?
That's your standard deviation. Yep. And then that's your t-score right here. So it's the same type of idea, z times standard deviation. It's t times your standard deviation here. But you have to adjust your standard deviation that you have in here, like your sample standard deviation, based on the number of students that you're using.
Okay, so instead of doing t times the standard deviation divided by the square root of n, can't we just write standard deviation times t times standard deviation?
Sure, but maybe put sample standard deviation.
Yeah.
Sure. But your sample standard deviation is going to stand for that.
And does it matter if you do the mean plus or minus the standard deviation times the t-score? Because that's how we did it the last time.
No, it doesn't matter which order, as long as you're doing this math first. Doesn't matter if that's written first and that's written second. Yep, doesn't matter at all. Adam, did you do some math for me? The t-score times the standard deviation? Okay. it's done the same exact way. If you were doing 99%, you'd have a different T-score. That's what would change on this, is the T-score for it. And if you had a different number of students, it would change that N value in there.
Did you like start writing it up there and then just switch to
Yeah.
writing it below it? Yeah.
Yes, I did. Mm-hmm.
think
I did.
Caleb
It was Caleb. Sorry.
What I do,
I'm throwing him under the bus there.
Yeah, that was you.
Mm-hmm.
So around to 3 decimal places.
okay, that makes a lot more sense now.
This is what we're figuring out is our interval. So we're not really like, it's not really an equation, we're just calculating. You're trying to find here and here. You're just doing math. It's an expression, so you're just calculating. These are going to be our intervals, and we're going to put it in a sentence, like we did the last time.
I got 0.5277, so
Let's see. I guess 0.5 something, right? Let's pull this up.
Is there a plus or minus operation in this calculator? Because it can do everything else.
Well,
I'm just answering the question. I'm trying to understand this.
well, technically it's two different operations, so I'm thinking the answer to that is going to be no, because you're going to get two answers. But yeah.
number 2.
I'm going to find it.
I'm gonna, for right now, I'm just gonna type in plus and see if that works. But Adam, did you do this math for me?
Yeah, I got 5.7.
Yeah, but it's 0.5.
528. It's 527.
5528.
5277.
5277. So 528. Okay. So we want to add together that. Now, Caleb, don't get obsessed with trying to find the plus or minus button. Just type it in plus and then type it in minus, okay? Because I don't think there is. I got 10.727, 673, something like that.
Yes.
Cool. Those are our two intervals, okay? So it's the same exact way that you interpret as well. We are confident that the interval, I do want to write it out though because we have enough questions about other things. We might as well write it out. From 9.673 to 10.72, whoops. 727 hours captures the true, do not put proportion in there, you want to put mean, the true mean number of hours of homework. Let's hear it, Caleb. Hit it.
How to do the plus or minus?
Didn't they give us the standard deviation?
They give you the standard deviation of the sample.
Are we using the sample standard
We
deviation?
are, but we need to incorporate how many people we sampled. That's where this guy comes from.
What if they don't give us the standard deviation?
Of the sample,
Yeah.
then you gotta, do you have the sample?
Yeah.
You gotta calculate the standard deviation. That's why I think for the practice problems for class and for homework, I gave two where it was straight up like this, and then the third one has the sample. So you have to calculate the mean, and then you've got to calculate the standard deviation. Now, it was like 20 things, so I just put it in as a spreadsheet and then did one variable statistics, and it spit it all out. But you're looking for this sample. It's going to be S of X in your calculator. That's what it's going to look like. So that's the one I want you to use. That's why I keep putting it up there.
Alright, so hold on.
That's it. All right.
The standard deviation that they gave you,
Yes.
what is that SX or is that SD or?
It's, look right where I put it. I put it right in place of this guy. So it's SX. It's the sample standard deviation.
SD is a real.
What is the
So
difference?
SD is what you're using now.
SD, I abbreviate.
Abbreviation.
Standard deviation.
This is garbage. It's numbers in math class. Why are we using
Hey, if anybody else wants to grab an iPad, all the rest, let's hear another question.
Okay, so they give you the standard deviation.
Yes.
Now that represents like all students, and then you need to say find the standard deviation of the sample, right? That's what they're doing here. That's what that means.
This means this is the sample of these 250 students.
That's the standard deviation of that sample, and then the one they give you is the total population, or right?
Which one? Like this little theta right here?
The top of that.
He's saying like
This right here?
It's not out of the screen, we can't see it.
Okay, this guy right here.
Yes.
That's the sample standard deviation.
But no, what does the whole thing represent?
The whole thing represents the standard deviation that we're, or the standard deviation of this sample of 250.
Good enough. Good enough. So that when we say we need to find a standard deviation, if they don't give it to us, we find one.
you do sample standard deviation.
When you're doing that in, like when you're calculating, like Tom said, when you don't have it, you find the S of X, but you still got to divide by the square root of how many people you're doing.
Okay.
Yes, sir.
What is the difference between SX and the B thing?
This is the population. And the problem is that on this formula sheet that you're given on the formula page, sample mean, it gives you stuff like this. So you have to take it into consideration that they're kind of meaning a few different things by this one. It could be the population. It's that sample population. They use the sigma in that. We use S of X a lot of times for that. I just want to show you what the formula sheet gives you.
And it gives us,
It gives you this right here.
It's in pain.
then why do we use S of X?
Because it's kind of the same thing. They're meaning like a general form for standard deviation, but we're using the sample standard deviation. So we want to. It just gets confusing when you're trying to calculate your own standard deviation. You look in your calculator. There's an S of X, and then there's also a sigma of X, and they're two different numbers. So I want you to use S of X. That's the only reason why I incorporated it here. Do you know what I'm saying? Okay. Let's try practicing. Okay, we got this written down.